So how do you separate odd and even numbers in Python? Well, I'm going to show you how to do that, because essentially I have a list from 1 to 10 of just odd and even numbers, right? I mean, an even number is something that is divisible by 2. An odd number is something where when divisible by 2, there is a remainder of 1. So how do we leverage that knowledge to essentially help us separate them? Well, I'm going to essentially use a list, because up to this point I've taught about lists, numbers, math, division. I have a video that I've showed how to do the modulus operator, which will essentially give you the remainder value, whether it's 0 or there's something left over. So if I kind of combine all that, what we would do is we'd say, so for val in our orig list, right? And then if I run this print val, what you're going to see is it's just going to run through and give us all of the values in our list, just one by one. So we can use that to our advantage by essentially just saying, combining our knowledge of if statements and say, hey, if our value is divided by our modulus 2, so what I mean by this, divided by, so if I say how many times does 2 go into our value and the remainder is 0, meaning it goes in perfectly, that it's even, then I'm going to essentially just say evens dot add or append to our list that value, right? And otherwise, this again goes back to our knowledge of if-else blocks, we can just say odds dot append value. Now, let's take our information and let's just go print and we're going to use some F strings here. We're going to say orig list is equal to that. And then let's go print out our odd and even list and see if they actually separated. So now if I run this, what you'll see is that I have our original list, and then our evens look like, 2, 4, 6, 8, 10. Those are all even numbers that we know. 1, 2, 3, 4, 5, 7, and 9. Or 1, 3, 5, 7, 9, not 1, 3, 4, 5. So just like that, that is one way that you can, or basically, I think this is pretty much, I don't want to say it's the only way, but this is really the main way, because what you're doing is you have to identify, the algorithm is essentially saying, well, how do you determine what is odd or even, right? And we know from growing up and going to school and taking our math classes that an even number essentially is something that when divisible by 2, this is at least how I remember it. When divisible by 2, it is, and it goes into it equally, meaning that there is no remainder, that then there you have an even number. But if you say 3 divided by 2 is going to be a remainder, there's going to be a remainder there because the 2 does not go into 3 equally, then you have an odd number. And so that's why 3, 5, 7, 9 are all odd. Now, this is basically how you would do it, and what you can do to separate this, and let's talk about now, like how fast this is, right? Like, is this really the fastest way that one can do this? So let's start talking about that right now. All right, so to check the time on this, I'm basically going to import our time module. And what I'm going to do is essentially just time this, right? So I'm going to take a timestamp before I go into doing this. So I'm going to say start is equal to time.time. So that's going to give me a timestamp there. And then when I exit the for loop, that essentially should mean I should have separated everything. I'm going to say end is equal to another timestamp.time. Now this will give us a timestamp in seconds. So now what I can do is basically get the elapsed seconds. So elapsed seconds is going to equal to end minus your start, right? And that should give us our number of seconds it took to run this whole block of code. So if I run this, come down here and I can say elapsed seconds is equal to that. And then if we rerun our program, we get something like, holy cow, that's a tiny number. So let's kind of just format this. And this is a nice thing about F strings is basically you can say, if you do this syntax equals, it'll give you the variable name, right? Just print that out. And then equals to, and then its value. But what happens if I want to, say format this string? What I can do is go to colon. And I want to do it to say, let's do dot 8, decimal places. And now I want to make sure I put in this F to show that it's a float. If I run this again, you should see that really that's only 8 decimal places after 8 places after the decimal point. And look at that, it's really tiny. It's like, that's really tiny. So it's pretty fast, right? And that's on just 10 values. And I can run again. This is going to vary each time you run it because your computer will have different things, going on at the time. But let's say that we wanted to switch this from just our canned example of like, this is just like 1 through 10. Let's do like 1 through 100. Well, I don't want to write out 1 through 100. So the best way that I've found to do this is you can use the range object, which when you go through, a lot of times you'll see people use the range object for loops. So to say to go through like, 1 through 10 or whatever. Well, the range object, when you run, like it's going to put in a value. Now, if I put in 100, it's going to go from 0 to 99. So if I want 100 included, I need to go to 101, because what this will do is it'll stop at the value just before this. It won't give you that value. But if I run this, you'll see that our original list changes to this range object. But then, hey, look, when we go through it, we actually get like, here's all the even values, right? Like, and here's all the odds. Like, it did it. But you see how like our time that it took is, it went in one more decimal place than it was before. And now this range object is, I can convert this if I really want to see everything. I can convert this to a list object rather than the range object. And then this will give me the complete list of like, say, there it is, 0 to 100. And then you see like, hey, look, yeah, still the same thing. Now, if I go say to 1,000, 1 to 1,000 or 0 to 1,000, that's going to give us, it again went in one more decimal place. So you can see like, this is a lot of numbers. And even now I'm going to go from 0 to 10,000. And even with that, like, it's still pretty fast. We're in the, believe that's microsecond range, microsecond, I think, because we're not even a full second that we've gone, right? So if I again go to, what is that, 0 to 100,000, so 1 to 100,000, I print this out, and again, I'm printing everything out, but I am only collecting my timestamp here, so this is not the amount of number it took for our program to run. This is the amount of time that it took for this block of code to run. Granted, when you print stuff out in an application, because your computer's having to print stuff out, it's going to take more time. So if I were to time this whole thing, you'd see that it would take longer. But we're only timing this section of code, and that's valued right there, and then we're just printing it out down here. So again, 0 to 100,000 it's still not even a second, right? And let's go one more. Let's add another one. And you can see that after running this, the print takes probably longer than the actual amount of code. Yeah, see, we're even like just at 50. It's almost done. Here, let's do this, because that printing out is taking longer than I want. So let's just print out the time, because we're having to print those lists twice, and that's a lot. So let's do this. We run it. Boom. See, the printing just, now we're at almost a second. So if I do this one more time, this will take above a second, because on our average, every 0 that we've added, or every time that we've gone, it's added one more. But this is essentially how you can separate odd and evens, and so you can see it's taking a little bit longer. So right there, going, how many decimal places is this? So that's 10 million. Am I right? Yeah, 0 to 10 million. It took 3 seconds, almost 4 seconds to run. So this is still pretty fast, right? I'm going through 10 different, and I'm separating 10 from 0 to 10 million. I mean, try counting to 10 million. That's a long time. That would take you forever. And try separating as you're counting. Like, that would take forever. And here, a computer will do it in about 3 seconds using a for loop technique like this. So this is probably the best way that I would say that you can separate odd and even numbers. Again, it is still pretty fast, because if you're not, I don't think you'll ever try and separate that many things or numbers. You may, but if we just go down to 0 to 10, then what we'll do is, again, we're super fast. So you can see how fast that executed. So if you have any questions about this, please leave them in the comments below. Remember to like and subscribe to this channel so we can learn more about Python programming and just software development and programming in general. And until next time, keep on programming.